Hello, I'm Scott Stonham from Tech, and today I'm joined here by Phil Sheppard. Phil, do you want to introduce yourself?
Well, Scott, yes, I'm Phil. I am a principal consultant and director at Clear Technology Consulting, which is my consultancy business. Prior to that, to the end of 2019, I was working as director of strategy and architect at the mobile operator 3 UK.
Brilliant. So Phil, we're here today to talk about 5G. It's a pretty popular topic, one that keeps us all busy, I'm sure. But what I wanted to do today was just, tap into some of your insights and some of your expertise to understand a bit more around 5G from a technology point of view, but maybe some of the things that we've not talked through, or the industry's talked to death, if you like.
Yeah.
So I think one of the things that I get asked a lot recently, particularly over barbecues and that kind of thing, is, well, what's the difference between 5G and 4G? And I think, we've, in the industry, we have that magic triangle, which talks about, the latency, the throughput, the number of devices and all of that stuff. But beyond that, what do you see as the kind of key differentiators, if any, from 4G?
Yeah, it's a good question. And the magic triangle, we've all overused it somewhat. The magic triangle really represents the requirements for 5G rather than telling you what is actually different from a technology point of view. So from my point of view, I'll highlight a few of the key differences between 4G and 5G. So first of all, 5G in essence is not massively different from 4G. So it uses similar spectrum frequencies. It uses similar types of technology to modulate radio signals. But there are a few particularly important big step changes that it provides. So the first one probably to highlight is that more spectrum has been made available to be used for 5G. More spectrum means more speed, more capacity. And the 5G specifications allow the technology to access more spectrum in one go. So it's called carrier bandwidth. Carrier bandwidth for 5G is 100 megahertz. For 4G, the carrier bandwidth is 20 megahertz. So you can see already 5 times more bandwidth that's accessible by the technology. Another thing that they've done is they've really changed the architecture so it's a little more flexible. So just a couple of examples. It's very much more granular in the way it can connect to devices and assign resources. So you can connect very many more devices to 5G than you can to 4G. 4G actually can connect quite a lot of devices too, but 5G really expands that a lot. The other architectural piece that goes on in 5G is the ability to do what they call network slicing, which allows you to, in software or potentially in hardware, but usually in software, to separate your network connections out into a slice all the way end to end. And what that does is it allows you to guarantee certain performance characteristics like latency, throughput, etc. And that's a big flexibility that 5G has introduced that looks like it's going to be really quite big. We can talk about this later in things like private networks and that sort of thing.
That's interesting. So on the bandwidth point of view, it doesn't just mean that we're all going to consume more Netflix, does it? Why are we going after this huge increase in bandwidth?
Yeah, I mean, it probably does actually, to be honest. It probably does mean a lot more consumer use. There's an average about 30 to 40% increase in data usage per customer and consumers. So for certain, that's going to carry on increasing, and that is a key part of it. But the other part of it is it enables new applications. So one thing I didn't really mention was the other thing with 5G is its latency is a lot lower, which means the delay and time it takes to send packets of data across the network is much shorter. By having a very low latency network, it allows you to do things that involve a human perception that you couldn't have done beforehand. So if you take, for example, a VR headset or an AR, in a virtual reality or augmented reality headset, if you want to move and have that respond quick enough, you need a low latency. Otherwise, you start getting a bit ill, or you can't actually respond and interact with things quick enough. So there are things like AR, VR that become a lot more feasible and a lot more human usable in a 5G network than they do on a 4G network. And then if you take it even a bit further and you go into some things like private networks, the low latency allows you to control machines in a much more safer way. So there's an awful lot of use cases on 5G factories where you can control the machinery very flexibly, move the machinery around. And because it's got such a low latency, if anything goes wrong, instantly it can switch off, and it's an extremely safe environment. Whereas for a 4G latency, it'll be a little bit too slow, and the machine can move too far in between, you know, connection going and stopping the machine.
Mm. And I guess, you know, in this time where we're kind of in this post-pandemic, maybe mid-pandemic scenario where people are, you know, beginning to work at home a lot more, and there's more distribution of the workforce. How do you see 5G playing a role in that future? Is it an important development to bring out now, to happen now?
I think it's going to be important for, you know, any forms of working out and about. And at the moment, obviously, the pandemic has shifted usage somewhat to home. And 5G has certainly got a use case for home. It's being used for fixed wireless access. There are certain homes that either cannot be connected or prefer not to be, or they're transient, sort of like student population, that sort of thing, where they prefer to have that. So I think it's got a use in the home, but it's also got a use out and about. A lot of the capacity is going into the major urban centres, and at the moment, of course, those are fairly lower usage than they used to be. But if we assume that at some point there will be some return to urban living, if you like, and urban working, even if it's not quite as high as it is now, then the capacity and speed it provides within that work environment is going to be quite important.
Mm-hmm. The slicing thing is something that's interested me for a few years now. Yeah, I think, yeah, from my understanding, you know, this allows us to have the possibility of creating new individual services for different entities, whether that's like a BMW looking to provide an end-to-end quality of service for its connected cars, or, you know, other global industries or even local industries. It sounds like it could overcome some really big obstacles that operators have to deal with today. What's your thoughts on that? Is it something that's going to be transformational, or is it just another incremental change?
So I don't want to be too hyperbolic on it. I don't want to be too over sort of pushing it, because at the end of the day, network slicing is a way of doing what you could have done in another way, but a lot more efficiently. So I think actually, although in a way it can just do everything, you know, you could have done everything like this by building your own dedicated network. The key thing is it's really efficient at doing it, and it's really flexible at doing it. So I think that's actually what's going to make it, you know, a useful tool to do. So, you know, I've seen use cases, for example, on ports. If you want a 5G network to control your ports, it's an extremely cost-efficient thing to do, and allows a lot of cost savings. You can build that network where some of it is shared with, like in the public network, some of it is dedicated to the port, and that slicing can be a combination of hardware and software that gives you a much more quicker way of getting that network up and running, and a more efficient way of running it, as well as guaranteeing the performance that you want as well. So it's got all pieces in it. So yes, I think, you know, I don't think suddenly, you know, it does somehow open up a whole lot of new applications, but it makes them a lot more feasible and a lot more possible to do. And I think that's where it will take some while. I think it'll be a long haul on this one, but I think that will become the standard, you know, way of building some sort of specialized end-to-end networks in the future.
Interesting. And I think, you know, two of the big areas that I've seen a lot of emphasis go into in the early days are what you mentioned earlier, fixed wireless access. So the ability to have higher speed internet access in places where you can't get the copper or the fiber, but also in the Internet of Things. So, you know, where do you see 5G evolving, particularly with Internet of Things at the moment?
Yeah, so Internet of Things is an interesting one, because the 5G requirements and what's come out in the standards allows you to do millions of devices per square kilometre. It's a huge number of devices. And at the moment, IoT, you know, is actually on 4G. You can do a very large number of devices already, and we haven't got anywhere close to that. So I think, in one respect, it's a requirement that is anticipating a future that isn't quite there yet. I think a couple of key things. One is that in my view, is that the IoT has to be standardized to make it grow. And in the past, there's been several proprietary standards that have been actually reasonably successful, and they're good, like proprietary solutions. But when you're in proprietary land, you don't get the massive device, you don't get a long-term support for it. And with the 5G IoT particularly having a very long-term future because it has a massive scaling capability, my hope is that it will sort of like finally unlock IoT in a really, really big scale, and it becomes a long-term thing. Because what you don't want to do is deploy lots of IoT devices and then find in 5 years' time you haven't got a network to connect to, and you haven't got any support because it's gone out of support because it's old technology. So I think they're some of the key things to me, and I think it will happen, but I think again it's going to be quite a long run on this one.
That's an interesting point because a couple of years ago we were talking about how IoT devices could have a 10-year battery life, which is fascinating because the technology will evolve so fast beyond that by the time they run out of battery, the networks will evolve beyond that.
Yeah, you might as well replace it then at the same time you replace the battery.
Yeah, but you pick up on another really interesting point here that keeps coming up as well. The use cases that we're talking about at the moment, many of them can be fulfilled through 4G.
Yeah.
So, why are we spending all of this time now rolling out these 5G capabilities, all of this expense and everything like that? Why do we do it now? And how long are those lead times?
Well, you know what, it's a good question. And actually, for some of the use cases, you could argue it's not worth doing now. You might as well wait a little bit longer. But there are some use cases that are here and now that are useful. One is just capacity. So there's more capacity is required. A lot of sites in the UK are getting extremely busy, congested, and there's new spectrum coming along. So, well, what do you deploy on that new spectrum? Well, you could deploy 4G, but why not deploy 5G? Because 5G has the extra flexibility. It's available technology now. So it makes, in a way, no sense to deploy loads of new spectrum and deploy it on old technology. So just simple common sense, if you like, in terms of capacity. And I think also then, it does even on just consumer use cases, it does really shift the performance. You'll be going from, let's say, 30 odd megabits per second on average on 4G to around about 200 megabits per second on 5G on average, and peaking up to higher. And that's a huge experience improvement. It really improves a customer's experience, even just doing what they do now. So I think that's still got a case for it. It's got a case in that it's a lot more efficient on capacity, or cost per capacity element is more efficient. And it does that partly because of the way that it uses spectrum more efficiently. And also because of a thing that I haven't really mentioned yet, which is the antenna technology. It's one of my personal favorites, which is massive MIMO, which I'm sure a lot of people heard about. And a massive MIMO is not massive antennas, they're just lots of elements in the antennas, which is why it's called massive. And it allows you to do a thing called beamforming, which really increases the coverage and the capacity and the speed that you connect it to. And that technology itself, even if you weren't doing 5G, you would be deploying now on 4G in the same spectrum band, because it is incredibly useful at multiplying between 3 and 5 times more capacity and performance out of that than a standard antenna.
Yeah, and again, one of the things you were talking about there is much of the 5G work, much of the reason for deploying 5G is solving some of the pain points we have today, but really creating a future proofing. Yeah. As far as we can see anyway, because I'm sure there's a 6G and a 7G going to come along behind this too. So we've got that future-proof scenario. We're thinking about the future. What kind of weird and wacky ideas are you seeing that people are thinking about in a 5-year, 10-year time frame?
Okay, how weird and wacky do you want to get, I guess, is the question.
Crazy as you can.
I'll go not terribly wacky first, and then go wacky with it. So, I mean, the one that's cloud gaming is probably one which is a new thing. I mean, cloud gaming is simply, normally on a network connected game, you would have a PC or a phone that has a lot of graphic processing, processing performance on it. and it would run all this sort of rendering of the graphics and on the device. So the device has to be quite powerful, and it has to be, quite use a lot of battery as well. Cloud gaming does all that hard work in the cloud, and then it connects to a device that simply displays a video and sends back control. The speed and latency that 5G provides allows that to work in a way that you can actually play games, like shoot 'em up type games, real-time games, in effectively and actually still like win games rather than being the person that's lagging behind everybody else. The 4G performance, the latency just isn't good enough. So that sort of is a performance step threshold that 5G allows that 4G doesn't. So I think that's an interesting one. It's been shown to work, but again, how popular it will be or not, but it certainly looks like quite a good opportunity to bring gaming out on mobile in sort of lower end devices. So that's one. Yeah, let's see what else. So I'm going to do one which I don't think is going to happen anytime soon is remote surgery. So remote surgery, in theory, with a 5G, as I mentioned about low latency and be able to control machines in factories, in theory, remote surgery becomes possible because the latency is low enough and performance low enough. And I think there might be some instances of that. The only thing is you have to have a machine that can do the surgery that's incredibly sophisticated and incredibly expensive, has to be moved to the location of the patient. And then you have to have 5G coverage there. Now, I'd argue you'd probably already have a fiber somewhere in some hospital or something to do it to. So it feels a little bit odd that you'd be having all that high tech availability, but not having an ability to have a fixed connection and something. But there are some maybe slightly less. That might happen, by the way. I'm not saying it won't, but it just doesn't feel like. But I have seen some use cases demonstrated recently, much more practical, if you like, where ambulances have been equipped with 5G and they've been able to do scans on the ambulance and send that back really quickly and diagnose things back at base. So I think that speed and sort of latency and interaction will be useful in maybe more less dramatic ways perhaps than the remote surgery, but certainly really helping the health industry.
So I've heard from several operators now, actually one again this week, of the idea of repurposing some of the cell sites to act as drone docking stations, and then using 5G to kind of 5G and blockchain. You've got to have that in there as well to allow people to kind of second these drones and use them for various use cases, from farming to security and policing, surveying, whatever. Yeah. And the idea is obviously that you need that, as you were saying, for cloud gaming, that real-time, instant action, live for that first-person view. I think there's regulatory concerns around that as well, about line of sight flying. But do you see that as one of those cases that could come true? Maybe not yet, but could come true?
Well, you know what, this is probably one. I mean, I've seen in the US there's been some success in gaining approval for using drones commercially, in terms of the flight permissions, etc. The capability that they have now, the ability to control it, as you say, with low latency, the AI type capabilities in order to sort of sensibly control that and sensibly do work. And I know that drones are being used anyway for things like surveying mass sites. It's being used regularly to have a look at that, because it's a safe way of getting up there. You don't have to climb, and you can do that. So yeah, I do think drones will have a very interesting future. It's very difficult to predict at the moment. Do you want drones flying all over the place? But they have a good place, because there are sort of benefits of them, and certainly the 5G latency gives you that ability to control them in a way that you probably otherwise wouldn't feel comfortable doing so. Mm-hmm.
Good. Now, just to summarize on kind of the three areas that we've talked about in terms of the parties that are going to benefit from 5G, we've got the operators that are going to benefit because of capacity. I think I'm not sure if you mentioned it, but 5G consumes less power from what I've heard from the operational point of view. spectral efficiency, that kind of thing. Yeah, do you want to comment on the power
Yeah,
piece?
I mean, I'm not. If you like, there's some techniques in the base stations that the newer technology helps to save some marginal amounts of power. I think probably what you're referring to mainly there is the fact that the spectral efficiency improves things like the massive MIMO antennas, the wide bandwidth. So it's not so much necessarily that there's a huge reduction in power. It's just that it's sort of more efficiently delivering per megabyte, if you like. It's more efficient. So I don't think it's going to suddenly change the energy usage profile, but it's the best it can do, if you like, with the spectrum and the power that it's got, I guess is what I say.
Okay, thank you for that. And then so we've got the operator use cases, those things, as well as we're slicing the ability to do things that you can do, but just more efficiently. You've got industrial and enterprise use cases, and then you've got consumer. Consumer tends to drive most things in mobile operators, but it feels like 5G, at least from a near term, has a much stronger enterprise offering. Is that right?
Yeah, I tend to agree with you, Scott. Actually, I think the consumer, ever-growing use of capacity, the ever-growing demands for performance improvement, that for certain is a use case, and nobody really disputes that carries on, through all the G's in mobile. And the operators need to deliver that capacity, and they need to deliver the performance, so therefore they will benefit. Bit of fixed wireless access is another case that I think is a part of the growth plan for operators. But I do tend to agree. I think the big thing that this unlocks, that 5G unlocks, is probably enterprise networks, private networks, etc. There's even been some spectrum released in the UK that is shared spectrum, where you can get local licenses, either indoor or outdoor, and that will allow people other than operators, or operators if they wish to provide networks that are dedicated to other sort of uses. So I think that, combined with the flexibility, the slicing, the architectural, and we didn't even mention cloud, because I can't believe we haven't done that yet. Cloud, the whole thing is 5G core network is based around a cloud architecture from the get-go. So that in its own sense makes it a software-based flexible technology. The RAN is becoming virtualized as well, so radio network. So that also will be sort of somewhat in the cloud. There's still hardware though required in that. And all of that, will give the flexibility to deploy more efficiently, more quickly, and with all the attributes that you need to deploy in private networks. Could be a campus, it could be a factory, it could be a port, etc. So I think that what I've seen, all the forecasts I've seen, and my own predictions are that over the next 5 years we'll start seeing a real big ramp up in that sort of private enterprise network usage of 5G.
Yeah, that's interesting. And then, so with those, I mean, you covered campuses, you covered ports, you covered manufacturing. The use cases there seem to be quite wide. Now, if I'm sitting in one of those kind of companies, should I be thinking 5G today, or what are the things that I should be thinking about in terms of understanding whether 5G is something I really need to be getting my teeth into today?
I think if you've got a business where you need a connectivity solution, you may be using Wi-Fi at the moment, or some 4G network, and you can see that the performance that 5G provides to you and the flexibility it provides can add value to your business. Can it be a cost driver? Can it drive your costs down, or can it allow you to do things quicker and more flexibly for your customers? I think definitely now is a time to start thinking about your strategy on it. I'd say network slicing, the 5G standalone networks probably won't be widespread around until probably the year after next. But there are implementations now, but I just think it won't fully take off until then. But start thinking now. If you're a strategist, start thinking about it. Don't jump too soon, because costs will be expensive and you'll be testing out the technology a bit. But in a couple of years' time, I think it will be fairly well proven, and it'll have ability to then move into it. So yeah, I definitely recommend having a think about it.
Brilliant. And I think on that note, if there's anybody out there who's watching this thinking, actually, I do need to start thinking about it, how do they get in touch with you?
Yeah, no, absolutely. Please just contact me. I have a website with a contact page, or I'm on LinkedIn. So it's cleartechnology.uk is the web address. No .co in the middle. I've had a few people miss that. So just cleartechnology.uk. So please do contact me there, or Phil Sheppard on LinkedIn as well.
Brilliant. Well, thank you for that, Phil. Very interesting. And yeah, I appreciate you taking the time to talk with us about it.
Pleasure. Good to talk as always, Scott. Thank you.
Thanks so much.